Welcome. Thanks for joining us today. We're going to be talking about V9 of the curriculum and in particular looking at algorithms and user experience, particularly with respect to years 7 to 10. And it's called Algorithms 1 because there's an Algorithms 2 where we'll dig more deeply into the changes to the algorithms section of the curriculum. This week, this is session 3. If you haven't seen the other 2 in this series, they're available online for you to go back. Just a bit about an overview of what we're going to do today. We'll spend 5 minutes just introducing you to the session and what we're going to talk about today. Then we'll spend about 15 minutes on pseudocode, and then we'll talk about flowcharts and how to use them for algorithms, and then user experience and the changes to the curriculum related to user experience. And then we'll do a little wrap up at the end. We're your presenters. I'm Sarah and this is Kylie. We've got some lovely photos there for you. And over the years, we've got a lot of different experience of the changes in curriculum that have happened so far and the policy that flows through the education sector. My background is in software engineering. I retrained to be a high school teacher and taught digital technologies and senior school computer science. Kylie's experience in digital technologies, digital solutions, design technology, and her experience has been in Queensland schools, whereas I'm from New South Wales schools. And Kylie's also had outback and urban settings. I'm totally urban. Our goals in this session today will be to navigate the Australian curriculum, show you how to navigate the Australian curriculum website to locate the content. And you do need a bit of help with this. And then we'll explain the differences between version 8.4 and version 9 and ways that you can address the content descriptions. And then we'll see how these link to the relevant general capabilities. We'll also demonstrate some practical examples and we'll share some resources to support your teaching and learning related to algorithms and user experience. Our focus today is going to be on the main changes to the curriculum, which are pseudocode, flowcharts, and then prototyping for user experience. Before we get into the nitty-gritty, we just thought we'd take a zoom-out view and show you where this fits into the process of creating a digital solution. So according to the Australian curriculum, these are the steps to create one, and we're going to be zooming in on the designing algorithms part. So that's our focus today, designing algorithms and the user experience. With the algorithms, just a snapshot of how it progresses across the year levels might be handy for you. And you can see where the dark blue line is. That is where we're focusing today. And you can see the complexity is gradually increasing over the years, up to the stage in years 7 and 8, where we're focusing on pseudocode and flowcharts and tracing of algorithms. And there's a similar sort of progression for user experience.
Okay,
yeah.
Sorry, Sarah. So in algorithms, what's new? It's very specific about specifying how algorithms are presented and to be dealt with by students. The version 9 also states the complexity that's required at every level along the way. And you'll see terminology such as nested controls and logical operators. It'll also state where prototyping will appear and how it's to be dealt with, and specifies how the design principles are applied to user experience. So the new version of the website can be a little bit tricky for people who are unfamiliar with it. So we thought we'd do a where do I find it page. So on the Australian curriculum version 9 site, it does differ from 8.4 in the way that it works. You select the learning area from the left and you make your selection. So you select the digital technologies and the year that you're after. Here you can see I've chosen digital technologies. The following page will invite you to click on understand technologies or understand the learning area. It's this one here that works better at giving you the information that you need as a teacher. And it's a little bit more friendly version. So what do I teach? The content descriptions that come up after we click on that button provide really explicit statements and help the teacher to organise content into a sequence that suits the school, the students and the community, because every school is unique. So the organisation between school to school will differ greatly. And then we've got some elaborations. In some states, elaborations are points which need to be met. And for the Australian curriculum version 9 especially, elaborations are suggestions. They're not essential. They're examples of how the curriculum might be handled by a teacher. They're really good to bounce from and to develop a plan to suit your own context. Some teachers try to tick them all off. It's probably not possible unless you're an overachiever, but it's not made for it. So you just simply look at one, think about it and go, yeah, that would probably suit for me, and tailor something that would maybe suit your school environment. So let's firstly look at years 7 to 8, because we'll be going all the way up to grade 10 in this presentation. So we can look at the achievement standard for digital technologies, and we can see that by the end of year 8, where they should land. And take note that it is at the end of grade 8. So you have 2 years to achieve this standard. And it's always really good to know where you need to finish up at the end of those 2 years. And the best way to work that one out is to read the first sentence of the achievement standard, and it gives you a fair bit of information or a summary about what it is that the students will be expected to do. And then it goes on in more detail. So in generating and designing under digital technologies for year 7 and 8, version 8.4, we call this algorithms. You can see here that it was a fairly complex statement in 8.4, and version 9, what they've done is that they've made sure that anything compound description has been split up to enhance clarity. By splitting up the long sentence, it helps us understand a little bit clearer about what we need to get done. More explicit, some of the differences between algorithms is specifying the how. So we can see here, it just asked you in 8.4 to represent algorithms diagrammatically. Now we're told that we're to have a flow chart, and that is the way that we demonstrate diagrammatically. It said the algorithms need to be in English. In other words, pseudocode is prescribed. And being able to split them in half does help a little bit. Here's some elaborations for the 7 and 8 in detail. So for that same one we were looking at, the elaborations let us see what could be possible, maybe some suggestions for different ways that teachers might look at it, and really good for coming up with ideas of how to implement the curriculum within your school. So looking at algorithms, you know, it always helps to go and have a little bit of a look at the glossary in case we're not entirely sure. So we've found in the Australian Curriculum Glossary, it's a series of steps or decisions that are needed to follow to solve a problem. So it's saying there that it can be used in pseudocode or flowcharts. They can be iterative processes, which, or I suppose repetition as it goes through. So pseudocode in particular, out of the algorithms, are little English statements that describe the steps in an unambiguous way. So it's a nice stepping stone to translating it from somebody's mind to code. It's that step in between. So it's often used by non-programmers to communicate what they're thinking. And if you think about the word pseudocode, pseudo means fake. So it's really is a little bit of a fake code, and it's somewhere between. It's not English and it's not program code. It's somewhere in between. And it's often used in the design phase to really quickly articulate those algorithms. And for example, a software engineer, they might use pseudocode to design an algorithm in a way that the client or the non-coder can understand. And it's a lot easier and a lot cheaper to pseudocode and communicate that to the client than spend all the money getting your software programmer to build a program that probably doesn't suit their needs. An example of pseudocode might look nice and simple like that. You can see that we have a start and an end, or a beginning and an end. You can see that we use indentation to try and group items together. So different ways we can write pseudocode: begin, end, start, end. Starts at the top, works its way down in a sequential order. There's usually one statement per line. We usually use indentation to group sections of actions together. And there's no real hard and fast words that you need to use, but some of the most common ones that are used across the board include these ones. And usually what they do is they capitalize them to make them stand out a little bit. Again, not necessary. And you can see here that here's a little pseudocode algorithm, and you can see that the algorithm deals with it sequentially from top to bottom. So the first item, the second item would be dealt with, then the third, then the fourth, and so on. It's all about getting out there and getting your gumboots on if it's raining. So again, you can see that indentation is helping us there in grouping together what would happen if it was raining. As a starter, you would probably go about giving a simple scenario to your students. I always find that food works. Chocolate's even better to motivate your students. Sometimes students develop the steps, and then they can test them out with me as the teacher, and I'll try to follow those steps. And, you know, it's always helps if the teacher brings out their interactor and tries to butter bread that's not there if the step isn't there. So this one here is all about making some avocado toast. You know, so I would think that maybe something like making some toast in the morning, something students are all familiar with, is a really good place to start, something sequential. They might be brushing teeth, it might be tying up shoelaces. You can see here we have a start and an end at the end. Then we've got moving into more complex algorithms. We would perhaps use the indentation for branching, such as if the color's blue, give them a nice little output. Otherwise, that's nice, but my favorite color is blue. It always helps if they're a bit of a cheeky reaction. So you would start by adjusting and increasing the complexity by helping maybe some branching, followed by perhaps some iteration. You might decide also to get them to adjust a simple statement like this, such as, what would happen if I entered red? What would happen if I entered blue? So you start to get them thinking about the way the code works and a little bit of tracing, which will come later as well. You might extend the toast scenario with asking them if they like some butter. For students to interact with really complex algorithms, it really helps to distribute to them an existing pseudocode and ask them to adjust it in some small way. Again, following the I do, we do, you do stage release of learning. There usually is a really good pedagogy in linking the known to the unknown. So maybe add an extra feature, maybe add a repeat within an existing if statement, Or you might ask the user another question, such as the butter, or maybe even provide feedback to the user. So to get the students to adjust pretty complex code gives them a bit of a view about what code looks like, or pseudocode, excuse me, looks like, and how they might interact with that. Students then perhaps might be given an opportunity to design their own code. And sometimes pairing them up with an elbow partner can be quite useful because they've got someone to bounce off. If you've got those students who get a little distracted on the computer, I always pull out the paper and the pencil to get the algorithm done and dusted. It's so much easier for students to show algorithms to each other or pseudocode if it's on paper and it's right in front of them, and they tend to not get so distracted if they're not on the computer. And it also helps too if it's on paper, they can annotate any changes that they need to make along the way. And I find it really helps to give them a bit of time limit for any pseudocoding activity, so that they can articulate it and then they know it's an endpoint, because you don't need hugely complex programs. You simply need them to engage with it to some degree. And tracing and checking of that is quite a large part of algorithms. So it might be a knock-knock joke. You might ask them to make sure it has iteration in it, that it has some sort of user input and output to the user, some user interaction, and maybe a little bit of branching in there. And it's quite interesting what they can come up with. The Australian Curriculum version 9 continues along with the vein from 8.4, where it includes general capabilities, which are to be addressed across all the learning areas. And if you are giving your students an activity such as this, you're transferring knowledge, and that's a critical thinking capability. You're also planning, creating, communicating, collaborating. Well, that's your digital literacy. So there's several times throughout your learning experiences where you can address those general capabilities as you go along. And then to give them a more complex structure, it might be something such as a choose your own adventure algorithm to be written down in pseudocode. You know, a dark cave opens, which do you do? Do you go inside or do you get out of here? And then now you're standing at the fork in the road. Do you go left or do you go right? And so on. So they love getting a little bit creative with this. And because this has nested branching within branching within branching, it can get quite complex, and it really does test them out about where their indentation is to make it quite a clear communication of the algorithm. And about this point, and when they've started to interact with pseudocode and they're quite complex, it often helps to give them some algorithms to write, which would include actions that are repeated throughout, such as praising if they get an answer correct, that is quite repetitive. So it's a good opportunity to simplify and to help them make the algorithm more efficient and show them modularization. And that way you can introduce functions before getting to the actual coding. So modularization is introduced in 7 and 8. So introducing it into your pseudocode does make sense. So as you can see here, we have a program called mind reading, one called correct, and one called wrong. And you can see here, if the user enters a cat, it pulls the pseudocode called correct in. So it goes over here and it says, you got it right. Okay, here we go. Otherwise, if they got it wrong, it goes, no, that's not it. Try again. So instead of us having to repeatedly pull these in and write them in the main code, we have them sitting on the side and they're summarized in just one word. Makes it nice and easy. And the students can start seeing how useful the function is, because they're all in about being efficient and doing less work. So you sell it to them like that. So we've done algorithms and pseudocode, and now it's also flowcharts is something else they need to interact with. And that's more of a diagrammatic rather than an English version. There's all these steps and different symbols and arrows that indicate the sequence of an algorithm. And some students prefer pseudocode and really engage with it. Some students prefer algorithms and they really engage with them. And the curriculum does encourage us to allow them to experience both. So they look very similar in the steps are sequential from top to bottom. So here we have pseudocode, and this is how pseudocode would look as a flowchart. So they'd stop at the start at the top, work their way downwards is usually the way it goes. Though I have had several students who insist on going sideways or up. So the direction of the arrow is really important. And some do go a bit wiggly by the end of the page. So the arrow is to be followed. So they're not too different. You can see that there's shapes involved, you know, and it might be worth having a quick look at those shapes. So rather than words for the syntax, we've really got shapes, and they're recognizable across the board. So it helps to have a standard shape for students to be familiar with. So start is usually an oval shape, and usually we place it at the top of the page. And the symbols that you use, such as the colors, are not essential. And when I'm getting students to document it on paper, I don't ask them to color it into a certain color or anything, just as long as the shape indicates what I want. A process is an action. So you can see here we've got do this. So that might be butter your toast or set the number to 10, but that's do this. So in pseudocode, we had do this. In a flowchart, we would have it in a square box with the statement of what we need to do there. A decision is a diamond, and it's branching. It's asking a question, you know, is the, you know, one or two options available, such as is the color blue or green? And we can have the answers coming off each of those diamonds. Squishy rectangles, they demonstrate when information is inputted to the screen, inputted from the user, sorry, or outputted to the screen or to some sort of added on device to the computer. So if they were inputting a guess, it would be a squishy rectangle. And if the computer was putting something to the screen, it would also be a squishy rectangle. And lastly, the arrow is the direction of the decision to follow. So you can see that the pseudocode equivalents are to the right, so that students can transfer what they know to something new. So whether you start at pseudocode or whether you start at flowchart doesn't matter too much, as long as you allow students to experience both. So here's another. The pseudocode's on the left, the flowchart's on the right. And for me, paper's your friend. You know, despite being digital technologies class, I find students design faster and clearer using paper. They do resist a little bit, but it works so much better. Students can quickly articulate algorithms, they can trace, they can modify and improve using paper. And if you encourage them that neatness is not as important as the concept and the flow and the color, then the idea going through, they usually will be able to articulate this as they go through. Note the branching here. You've got a yes or no answer, and the yes can be continued to meet up with another action which follows. So you can follow that one through or here. Okay. One of the things that we need to do is sometimes to trace our algorithms to predict an output. So in order to do that, you can do it with a pseudocode or you can do it with flowcharts. And it's to check that the student can follow the flow and the instructions. So usually I think it's in grade 7 and 8, they're asked to trace an algorithm, predict output for a given input, and to identify any errors. So I would give them something such as an input. What would happen if I was to input black? And that you could use something such as this, which is a desk check, where any of the variables would be written down, any of the output would be written down as you go through step by step. The other thing you could do is ask the students to write next to the flow chart the answers as it goes through. So in the desk checking table, they would enter the information as it goes down, such as what the lolly count is as it changes and goes through the loop several times until it shoots out to the other side, and what the result is. So if I entered black, what would happen? Hopefully they come back with that's yummy. So you might start with a simple version of this with a bit of a trace or a desk check, and you would test it out and slowly get a little bit more complex. Pseudocode's really good for that linear logical flow. And flowcharts are really good for those students or situations where you need to visualize and trace. Students will usually express a really clear preference to which one they prefer. So as long as you give them opportunities to work with both, it'll give them that idea of being able to communicate in the way that they need. So as you can see here, the flowchart is really quite good at diagrammatically communicating quite complex algorithm, but in a digestible format. Whereas pseudocode, there'd be a fair bit of indentation and if-thens, and it would probably be quite a long code. So sometimes flowcharts are your friend. Now we'll move on from algorithms and into the world of user experience. UX is part of the interactions and impacts of designing a digital solution. So usually students would tackle user experience within the design phase of the process, so at the beginning. And difference between 8.4 and 9, version 9, is separating quite a complex descriptor into more distinct parts to help in clarity. So on this one particular, note the addition of modify, which wasn't in the 8.4. So now they must also modify alternative designs. So they need to change, they need to adjust, they need to improve. So that's 7 and 8. So students are required to design the user experience of a digital system, and digital systems can be really many and varied. So it could be a game controller, that could be a digital system, it could be an animated diorama garden. To bring the garden alive, you know, you might have your microbits and your motors or your LEDs in there. It might be a mobile phone app or a website that you're getting them to create. All of those are digital systems. And all of these would involve, in order to design the UX of a digital system, my favorite method, a paper sketch. So sometimes for mobile apps, younger students, I'll provide them an A3 template for those that who prefer those neatly ruled lines. So let's say I was doing the mobile app for volunteers. I might provide them a little template for all of the mobile phones for those students who like it. Other ones, I'd just ask them to draw, say, the rectangles on the screen. But some students have trouble without having something semi-realistic in front of them. And again, paper and pencil, no color needed at this stage. You're doing the first prototype, not prototype, but first version of the sketch. And you'll be doing several of these because there needs to be several designs depending on it. And they might go on and show you how the interactions, so if you pressed this, where would it open it up? Would it open up to here? So sometimes a different colored pencil or pen to show the interactions of where and how the app would work really well. Okay. To give that real world purpose to the prototyping, I would always give them a purpose. So what does the digital solution have to do? So that's the what, this is the do, what that has to do, the purpose. And I would also give them an audience. It's very creative for the students, and it really ups the level if you can actually pull the audience member in for user experience testing later on. So it helps because they've got an audience that they have to present to as well. So when they create several designs as their options, they do their quick sketch for me and they test it against the original brief. So is it suitable for a Year 1 student? Does it help to bring joy of the outdoors to those people? Is it interactive? And does it use microbits? And I should be able, in that drawing, that annotated drawing, I should be able to see parts of that. So I should be able to see the microbit, the interactions, the LEDs, if it's going to use that, the fabrics or the backgrounds of it. So it's a rough sketch, and the annotations are the what and the when. No extra points for colors or being able to draw a bird better than me or a flower. And, it really helps if you can include this process within maybe an assignment format where they follow the whole design process through, from analysing the user, communicating the criteria, clarifying what the user needs, and then doing the designs and modifying. So to satisfy the need to modify in this instant, it could be as simple as using a different coloured pencil to annotate the change or the improvement that they've come up with. And what about Year 9 and Year 10? Well, again, we have an achievement standard. And again, we've got 2 years to get there. So every school's so different. Some schools will allocate a term, some will allocate 1 lesson a week. So they're all different. So this accounts for that. So again, we read the first sentence of the achievement standard to get a bit of a feel for where they'll end up. And then there's more detail under it again. So in years 9 to 10, the differences are very similar. Again, you can see a complex statement in version 8.4 has been broken up into 2 distinct parts to help in clarity. Again, flowcharts and pseudocode replace the words diagrammatically and in English. There's now logical operators are clearly stated. And algorithms are not just to be traced, but compared against the output against a range of cases. So as this differs slightly from 7 and 8, we won't revisit pseudocode, flowcharts, and tracing, but we'll have a look at where it does differ. There's your elaborations. There's still a way or a suggestion to implement suggestions. Again, they may be read and taken on board, or they may be disregarded. You may choose to include something similar or something completely different depending on your school situation. And if we have a look at user experience for years 9 and 10, let's have a look at what's different here too. Again, a complex descriptor is split into 2 clear ones. And also have a look at the top one. There's now the addition of not just designing the user experience, but they need to also prototype it. Okay. Okay, so once again, it's part of the design of a solution, but it's not an algorithm. So prototyping, that could be quite an interesting thing for us to look deeper into. Your elaborations for user experiences gives a few examples of ways that you may or may not implement that in your work and your learning experiences. So prototyping is a trial model or a test an idea. So the purpose is to see if it works well and to test by the users. Unfortunately, most students think that they are the user, but they need to have it work through their head that perhaps users are the original purpose of the project. A thing that it is to be tested by users, and what it isn't is a ready-to-sell item, and it's not a finished product. So by ensuring that students do not feel that they have to build the whole website, a prototype would have one arm of that website finished rather than all of them. It's a start, it's a simulator or a first version of a digital solution rather than the whole, tied up, ready to go one. So some sort of prototyping methods that you could go about it is something like slideshows. You might decide that Google Slides, Keynote or PowerPoint are your friends there, because they can actually have hyperlinks to other slides within a slideshow, and it could almost interact like a web app or a mobile phone app. And it can mimic the user interaction enough to test with users. Some other options are listed there: Balsamiq, Figma, Adobe. The XD Adobe has a pretty schmick prototype for web apps and for mobile apps, but it comes at a huge cost. And of course, with all those software tools, we're sometimes limited by the security requirements of the education area that we're in. For example, single sign-ins or blocked sites or, unsupported software within your school will ensure that everybody needs to find their own solutions in line with their policies. If I was doing a game controller, it might involve a cardboard mock-up or a 3D print or a paper mache model, something you can hand to the user in order to test it out. If it was an interactive display, such as the one with the really badly drawn bird in it, we might get a cardboard box and actually build the first version to test it out with the prep students or the Year 1 students, maybe. And again, make sure that you set a timeline for students when they're building a prototype, because some of them will get stuck on the idea of perfection. Prototypes are not perfection. They're really like crash test dummies. Crash test dummies are not real humans. They barely look like a human, but they're a rough prototype that enable us to use in a test with the users. So students shouldn't feel that they have to have something completely humanoid or an amazing game controller. It is going to be a prototype in order to test with your users. And as we're going through each of the activities and learning experience with students in digital technologies, there are several opportunities to embed the general capabilities for version 9. Here's a couple of them. In the creative and critical thinking general capability, if they identify and process information, or if they consider alternatives or put ideas into action, if they interpret problems or draw conclusions, then those learning experiences are addressing the general capabilities. And digital literacy is similar. If they're locating information, planning or collaborating with others, and, respecting intellectual property, again, there's so many opportunities throughout. Some work programs and units of work that teachers create, they ensure that they put maybe an indicator of the logo next to the learning experience to make sure that they understood that they're addressing not just the learning area, but the general capabilities at that time, and giving students several examples and opportunities to address these.
Thanks, Kylie. There's a lot to absorb in all that. So I'm sure that the audience will be busy checking out all those examples. That concludes the end of this week's session, Algorithms Part 1. We'll be meeting you again for Algorithms Part 2. But thanks for joining us, and we hope you found something to take away that was useful. Here's some further resources that you might want to dig into. There's some on algorithms, some on trace tables, flowcharts, and then a couple on user experience there. So we'd like to say thank you. Now the Grok Academy platform is free for all schools, in case you missed that announcement. And this is a 5-year partnership between Grok and WiseTech Global, so that we could make these tools available to every Australian student, teacher, parent, and even adult learners for free. Our mission at Grok here is to educate all learners in transformative computing skills, knowledge, and dispositions. So the partnership with WiseTech removes the financial barrier to schools to use our resources, and it lets us expand our team so that we can continue to support schools, teachers, and learners. So that's it for us today, but if you'd like to know any more about what we've talked about today, feel free to email us at the address there, or you can scan the QR code. Thanks very much.
Thank you.